Okay, friends. So this is the last algorithm what we will be seeing. Okay. So this is round robin scheduling algorithm. Okay. So the name itself says that round robin scheduling means the processes are executed one after the another. But what is this twist over here is they will be giving you the time quantum, right? So the time quantum, if it is given, the time quantum can be given as 1, 2, 3, 4, anything. But I will be solving this problem with the time quantum as 5. Okay, let me just explain what is this time quantum. Okay, so round robin scheduling is by nature preemptive in nature. Preemptive means what? The process which is in the phase of execution, we are terminating it forcefully and giving the CPU for the other processes. This is what is the general meaning of preemptive, what we have understood. So let us see here now. I will try to help you to understand what is this round robin scheduling by this simple problem. Okay, so here we are having six processes. The given time data will be the arrival time and burst time. As usual, we have to calculate the completion time, turnaround time, and waiting time. Completion time, you will get it once the Gantt chart has been run. The important thing is how to draw the Gantt chart. For all the problems, if you rightly draw this Gantt chart, so your 80% of the problem has been solved, right? So carefully understand how to draw this. This is bit, what you can say, bit different from all other algorithms. Okay. So first you sort it according to your arrival times. Arrival times here, if you see 0, 1, 2, 3, 4, 4. So make one queue. Let us make one queue and arrange the processes in the arrival time, which is the first process which is arriving. That is P1. Next is P2. Next is P3. After that, you can find both P4, P5 and P6 are arriving at the same time. P5 and P6 have arrived at the same time. Correct. So now, what is this time quantum means? When I have given this time quantum as 5, it means that every process will be given with 5 units of time for the execution, right? So which is the first process which will be taken for the execution is P1 because it has arrived first, right? So P1 will be given with the CPU for how many units of time? For 5 units time. Irrespective, the burst time of that is what? 7. It will be not given with 7 complete units of time. We will just give only 5 units of time. So once the process P1 has been executed for 5 units of time, the remaining units of time is how much? 2. Okay. Still 2 more units of time is needed for process 1 to complete its execution. But here we are preempting it and we are giving the CPU for the next process, that is P2. Okay. That is what is the meaning of your time quantum, and that is what is round robin tells you all about. Okay, here we are fairly distributing the CPU equally for all the processes over here. Process P1 has already, what you can say, taken uh, the benefit of the CPU execution for 5 units of time. So now P2 will be hand over it. So process P2 will be taking the control of the CPU for execution. So what is the burst time of P2? It is 4. Now tell me, as the quantum given for that is 5 units of time, it needs how much? Only 4 units of time. So definitely this will be completed in 5 units of time. See here, P2 takes the execution time from 5 to 9 because it needs only 4. 5 plus 4 is 9. So by the ninth unit of time, P2 has completed its execution. Once P2 has completed its execution, who is next in the queue? It is P3. So next process which will be running is what? P3. What is there? What is the quantum of P3? Sorry, what is the burst time of P3? It is 5. So, but how much time it is given now? Only 5 units of time. So, how much is remaining? 10. So, see here, P3 starts at 9 and ends at 14. It has not ended completely. It has partially executed. P3 is also partially executed and P1 is also partially executed. P2 has completed its execution. P1 is still needs 2 units of time and P3 needs still 10 units of time. Okay, after P3, who is taking the CPU? P4. Okay, that is, it is actually needed with 11. So 11 minus 5. 11 minus 5 is how much? 6. So still it needs 6 units of time. So see here, P4 is running from 14 to 19. Similarly, next turn is taken by P5 and then P6. So this is how it goes on, P5 and P6. Now once this all processes have been run, once again it starts with P1. P1 is needed with how much units of time? Only 2 units. But it is available with how much? 5. So can it complete it can complete its execution? Yes, of course. P1 here completes its execution. It starts its execution at 29th unit, 30 and 31. It will complete its execution. Why? Because it is remaining with only 2 units of time of execution. So P1 completes its execution. P2 has already completed its execution. So next process is P3. P3, can it complete its execution? No. It partially completes it because it is having how much? 10 units more it needs. But we have given the time for what? Only 5 units of time. So 10 minus 5, still 5 more units of time is needed for P3. Okay, after P3, it moves to P4. Can P4 complete its execution completely? No. It needs how much? It needs 6 units of time. So 6 minus 5, it is having still 1 more unit of time to be completed. Can P5 complete its execution? No. This also will not complete its execution. Can P6 complete its execution? Yes, already 5 it has been executed. Still remaining is what? 4. So when P6 starts its execution at 46, it completes it at 50. So P6 has been completed. Now, once again, it goes over here. P1 has already completed its execution. P2 has also completed its execution. P3 is partially completed its execution. How much is remaining? 5. So it will take from 50 to 55. Now this has been also completed. P4 is remaining how much? 1 unit of time. You can see here. So it will be running from 55 to 56. It will not utilize all 5 units. It will utilize only 1 unit because only 1 unit is remaining. After P4, we will go to P5. Okay, so P5 entire thing it will be running, that is 56 to 66 because 10 more units are remaining as there is no process which is waiting yet. So all the required, that is 10 units of time, is completely utilized by P5. So seeing this giant chart, we can easily calculate the completion time now. Okay, so seeing P1, where is P1? What is the completion time of P1? If you see this entire, scan this entire queue over there, P1 has completed here. Okay, P1 has completed at 31st unit of time. So completion time is 31. P2 has completed, scan it over here. P2 has completed it in this slot itself. So what is the completion time here? 9. Similarly, I can easily calculate the completion time of all other processes seeing this change chart. Once the completion time you have attained properly, it is quite easy to calculate your turnaround time because you know the formula. The turnaround time formula is completion time minus arrival time, right? So completion time is how much for P1? It is 31. Arrival time is 0. 31 minus 0 is 31. What is the completion time of P2? It is 9. What is the arrival time of P2? It is 1. So 9 minus 1 is 8. What is the completion time of P3? 55. Arrival time is 2. 55 minus 2 is 53. Similarly, calculate this. And waiting time is simple formula, that is your turnaround time minus burst, right? Turnaround time for P1 is 31, burst time is 7. So 31 minus 7 is 24. Turnaround time for P2 is 8 and burst time is 4. 8 minus 4 is 4. Similarly, calculate it for rest of the processes. Now, as you know, the last thing is you have to calculate the average turnaround time and average waiting time. How to calculate this average turnaround time and average waiting time? Sum of all this divided by 6. Divided by 6, why? Because number of processes are 6. And average waiting time, sum of all these numbers divided by 6. Okay. So this is how you will be calculating your average turnaround time and average waiting time in round robin scheduling. Okay. So please focus on the how to draw this giant chart. Okay. If you have done with this giant chart, your 80% problem has been solved as I told you in the previous video. Clear with this? Okay. Hope so. The problem is clear. Okay. So let me end the video. Thank you. Thank you very much.